B, and this one is D respectively. Are you able to see how we can identify this? All right, so how about for local backup? So local backup, the keywords here is within the same substations as the primary protections. We know that the primary protection at substation C, right? And whenever it's not working, so this is the one that able to detect, right? And then if able to open up to isolate the fault, right? So in such a case, we can say that the bus coupler itself, the tie couplers here, as well as this breaker 2 here, work as the local backup to trip this fault. Are you able to see? So that's how we identify the answer here. So do you have any questions relates to this example? Hello? Confirm that I ask you. So seeing as here, right? Substation C here, we also have breaker 4 and 7. Why do we identify this as the local backup for this fault? Can you try to think why is it so? Hello? Hello? Difference protection zone. No, memang itu backup is from different protection zones. I mean, this is the zones for this particular faults, right? That happens between C and D. You can see these all is from different protection zone. So the reasons why number 4 and number 7 is not considered as an answer for the local backup is because of this bus coupler. It's already open as a backup. So if let's say it's already open, which means that this fault current unable to travel down. So this number 4 and 7 here is not being listed as the local backup protections. Are you able to see now? Hello? Boleh faham kah? Do you have any questions? Can. So for such kinds of question, it's very important that I think I'm giving the tips right now. So we have tutorial 1, right? This Wednesday, you can try out the first questions we have. Okay. All right. So again, right, for the remote backup, usually is much more slow in terms of tripping the fault as the backup. But we can save money as comparing to local backup. So usually we will not duplicate the same kinds of protections within the same locations, right? That is the difference between two. So what we can say, the local backup has much more greater in terms of sensitivity to clear the fault, has faster operation times, but for remote, no, okay? It has lower response instead. All right, so do you need to have breaks right now, or I should directly continue for our last topic? Do you still able to capture? Hello? Continue, confirm, All right, so that is also another important topic as well in chapter 1. So we will start to look into what is known as directional protection scheme. But before this, right, we need to know what is the limitations of non-directional protection scheme, which is the conventional power protection system. Right, so if you look into this example, right, let's say we have a radio distribution system where we have transmission lines split into two via the bus bar, and this line itself is split with one generation source. All right. So at each zones here, these two lines here, we have implements with its own protective relays. Let's say R1 here and R2 here. So we know that whenever we look into this faults, right, let's say we have F2 here, we have short circuit occur at this particular point. We know that this R2, the relay, will work as the primary protection to trip this fault, right? So what happens if we have a how to say it, we have fault occurs here at F1. Same as well, we will have relay 1 here work as the primary protection to trip this fault F1s. But for this fault here, right, at the ends of the line, right, if let's say we are not implements with the directional protection scheme, which indicate that whenever we have fault occurs here, if let's say this relay 2 doesn't trip, right, this relay will able to detect this fault as well. That's why it's mentioned here. Relay 1 will trip for both F1 and F2, but for relay 2, it will only able to trip this F2 instead, right? In the situations, if we have generation source at one side. So see, as we know that this relay 1 should work as the backup for relay 2, right? If let's say it's filled as the primary protections, so that we only will have these sessions being isolated from the power network. Let's say there's a fault occurs instead of entire system, right? So what we can do, we will have time delay for this relay 1, all right? So that is the standard way where we can set backup for this relay 1 here to work for this faults, right? So that is no issue. Let's say we are using non-directional protection systems. So what happens if, let's say, we have these conditions? So we have networks, and this time we have 2 generation source at both sides. So this is only one side. So this is both sides. So what happens again? We have line being divided into numerous sections via the substations or bus bar A, B, and C. Let's say we look into these 2 zones. So in between substation A and B, this particular line, we have implemented these sets of relay. Same goes for B and C here. All right, so we have relay 2. So under these situations, right, with 2 generation source at both sides, if let's say we have fault occurs here between B and C, because of these 2 generation source, this fault current will actually travel at both sides, to the left and to the right of this system. So which means that we know that this relay is able to detect this fault because it's travel this side and this side, right? But at the same time, it will travel to here. So it will, this relay 1 will travel as well. Same goes for the fault occurs here. So whenever we have fault occurs here, it will travel this side and this side. So this relay 2 able to detect this fault as well. So under this situation, if both of them, right, is non-directional protections relay, these 2 relay, if let's say fault occurs here, it will take action to treat this fault. So which means that these sessions will be being isolated from the power system. Let's say B and C here, no fault at all. Can you see? All right, so with such a case, right, we doesn't have the backup protections right now. So we have big sections of the power system is being interrupted. So how actually we can stop this from happening is where we only want to have, let's say we have 4 occurs here, only have this relay 1 here to route this fault, to trip this fault, but this relay 2 ignore this. The solution is to use the directional over current relay or directional protection scheme. So whenever you see directional, which means that right now, the relay is actually able to detect where does the fault is coming from. So with such a case, whenever we have this system, generation source at both sides, right, we can prevent the unnecessary openings of the protection system, and hence we improve the securities of power supply. So to further explain how that's being achieved, right? So usually for the protection system with directional feature is being labeled as such, or it has such kinds of symbols with arrow underneath. So let's say we have 2 relay 7 and relay 8, right? So if you see that that is an arrow either at the bottom or at the top here, right, pointing towards the directions of right hand side, this indicate that for this relay 7, we're only able to detect the fault that locate at the right hand side, but ignore those that occurs at the left side. So how about for relay 8 side? So with the arrow pointing to the left, right? So which means that look into the line, so it will protect or trip those faults that occurs at its left hand side. It will draw a line here, but ignore those that occurs at the right hand side instead. Right? So usually this arrow tells you the directions where the faults this relay can able to detect. So for example, if you go back to previous case here, so like in these conditions, the line divided into 3 sections with 2 generations source at both sides, right? So what happens if we have fault occurs at the center part, which is at the second zones of this transmissions line right now? And we know that each zones here has been implemented with a pair of protection system. So what happens if this relay is implemented with directional feature, which pointing to the left hand side? So under these conditions, this relay will actually ignore this fault. So in such a case, only those relay here will be being tripped instead where the fault occurs. So here is not being operated. That's how we maintain the securities of power supply for these specific zones. Are you able to see how does the directional relay here solve the previous problems? All right, so what we can say whenever we have generation source at both sides, or probably we have the match network, which means that it consists more than one generation source within the circuit, right? It form a ring networks here. So whenever we have fault occurs, we know that the fault currents will travel at both directions. That's why it causing the relay unable to tell where does the fault occurs in terms of origins. All right, so in order to solve this, we will use the directional relay instead. So how does the directional relay tell us the directions of the current flow? So if you go to the second bullet point here, is actually based on the magnitudes of the voltage and the current as well as the phase angle. So the magnitude itself telling you whether there's a fault occurs, and the phase angles between the voltage and current are telling you which directions is actually this fault current coming from. So for example, if you go back to this example here, with 2 generation source at both ends that feeding this line, which has been split into 3 different zones. Each zone has been implemented with the protection system, and this two is with directional feature. So this is actually sensing those faults that locate at its right hand side, this one at the left hand side instead. So let's say under normal conditions, right, there will be phase angle difference between the voltage and current. So what happens if we have a normal conditions, right? You will notice that if you plot the phasor diagram here in terms of voltage and current value, you will notice that each phase here, let's say we're A, B, C phase, now each phase we're carrying this rated current flow IA, IB, IC, as well as the normal voltage value VA, VB, VC. And you will notice that under normal condition with no fault at all, right, the current will lead in front voltage instead. Okay, so under this situation will be normal condition. So what happens if we have fault occur like this? All right, if you are referring to this relay, right, whenever we measure the voltage and currents for each phase, we will find that the currents right now lag behind voltage instead. So that's how it detects it. This is actually occurs within its directions, or we call it as a forward current direction. So under these situations, this relay will trip this fault. So how about for this relay instead, right? Sensing those that at left hand side here, right? So under this situation, if we have fault occurs, let's say short circuit, we know that the current will rise. That's how we know there's short circuit current, and the voltage will drop. Remember, this is for normal condition. This is, I mean, for the magnitude. This is for abnormal condition. So the voltage drop, right? So you'll find that now the current is actually leading voltage instead. So that's how it's know that that is located at the reverse direction. So even though there's abnormal change in terms of the currents and voltage magnitude, but this relay will ignore this fault due to this phase angle difference. So it detects that it's located behind, which is in reverse directions. So that's how does the directional protections relays works. Okay, so now we are actually reaching the ends of this chapters 1 here. All right, so there are some pictures that I can show you what happens if we have electrical fault occur. So for example, right now, we could have substation to be on fire due to short circuit. It could be. And this one is for the situations like we could have the smoking transformers here. But right now, this transformer is unable to sustain the high temperature generate probably because of the increments of current flowing through the transformer winding, or maybe this is the main pain of the transformer that is the damage causing the oil leakage. That's how it's operate under hot conditions, causing it to be on fire. And the next one here, due to the size of the transfer, you can see which is much more bigger. So whenever we have abnormal situation, it can cause explosions. All right, so now we have one last topic. Sorry about it. That is not the last topic. This is the last one. Only one slide. Don't worry. And this is not so important. You doesn't need to memorize this. So for information, right, for all protective device, right, there is a standard for us to use to specify the components whenever we are designing the protection system. So if you still could recall, right, just now you have seen the code of 21, 50, 51, right? And by looking at that code, I can directly tell you what does the relay is. That is the functions of that standard. And this standard here we create as the NC device code, or you create as the IEEE standard here. So basically, you can see that it's used to specify certain components we are using in terms of protective device. Let's say we have relay or the circuit breaker by just looking into this single line diagrams. So actually, it's a code where it allows you to directly tell us what would be the components that you already use on a schematic diagrams. All right, so here is just the overall of the NC code you can find for different protective relays. So just remember, just now we have uh 50, 51, right? So it's actually somewhere here. Is it 2021? Sorry, 2021. So you can see this is actually the distance relay. The 50 is actually, where is it? Yeah, it's here. 50, 51 is actually the overcurrent relay. So the tips for you, right? Let's say the one that is dealing with short circuit to ground, right? You will notice that it's being labeled with G, right? Which is ground, short circuit to the ground. Okay, so that's basically the functions of the NC code. So now we are reaching the end of today's lesson, chapters 1, whereby we have talked about why there's a need of power system protections, right? Because we want to reduce the downtime, reduce the damage, to ensure the safety of the people, all right? And we doesn't want to have the power outage. And remember, with only few days durations of blackout, it actually can cause loss in terms of money in GDP as well as the inconvenience to us, right? And we also have go through the topics what is considered as an abnormal conditions in the power system that you must be isolated from the system. The typical one we have overcurrent situations that can be happens on different components like transmissions line, transformer, over voltage situations, all right, due to the lightning strike or accidents, all right. That is the abnormal conditions that could cause the power interruptions in the power system. And we also have gone through this, the historical moments for the protective relay, what people has been done in the past up to right now. All right, so that whenever you want to do the research on this area, you know where to start. So that is on this topic. This is not so important as being mentioned last week. And the next one is the important topics that you have to focus in chapter 1 here, which is the basic requirements of the power system protection, how we rate it, whether it's doing a good job or not. There are 6 parameters we can use and 3 come with formulas, okay? You might notice that if you go through with the passive question, there's some question asks you to rate the performance like in terms of dependability, reliability, and security in numeric form, all right? And then after this today, we also have power. What is the components can be categorized as the protective device, like the fields are, the circuit breakers are, the relay are, the instrumental transformer, and what is their functions and how we can connect them. This is what we go through, and we will look into each entities in probably next chapters. right? Like in terms of relay, circuit breakers, the instrumental transformer in chapter 3 and all. And then we also have talked about how to categorize different kinds of fault, active, passive, durations, permanence or transients, or for the multi-phase system, symmetrical, asymmetrical faults. So there are different kind of faults you can find in the power system. And the most dangerous one would be the three-phase faults, and how different power system here can be divided into numbers of zones based on the components. And this is very important as well as we will need to know how to identify different zones. Let's say you are being given a specific power system, okay, in which after you divide into different zones, and each zone here will be implemented with the protection system. Some work as primary, some work as backup, and how actually we can implement the locals and remote backups, remember. All right, so that is example that you have to look into. And the last one here is in terms of directional features. So I forgot to mention that how actually you can differentiate the relay is with or without the directional feature. So for example, like this case here, if those protection system either is switch alike or in box like this, right, doesn't come with arrow. There are the conventional protection system here where it will detect the fault coming from both directions. But if let's say it's with this arrow like this, right, then yes, we can tell that this is the directional relay. So it will only isolate those faults that occurs within its sensing location. That's how we differentiate them in the circuit diagram. All right, so with such, that's all for chapter 1. Do you have any questions for me? Hello? No, so for information, if let's say for your study in the future, don't ignore chapter number 1. I think I have give you enough tips of as well lah, just now. Okay, so don't worry. In this Wednesday here, we will have tutorial class. Before the tutorial class, I will help you to do the revisions again. Okay, so yeah, please try out the questions we have for the tutorial only on the first question, because second question is actually relates with the contents we have in chapter 2. Okay, so that's it. So if you have no questions, so thank you for your time and I will see you on this Wednesday. Bye bye.